So in this video, we are going to see how to solve complex logarithmic problems. As you can see, these three problems are the ones that we are going to discuss today. So let's straight away move into the problem number one. So as you can see, problem number one, log a over b minus c equals log b over c minus a equals log c over a minus b. I'm going to equate all three of them to a constant as equals log b over c minus a equals log c over a minus b equals to constant lambda. Then from this I can write log a equals lambda times b minus c, log b equals lambda times c minus a, log c equals lambda times a minus b. So our requirement is to prove that ABC equals to 1. So now what I'm going to do is I'm going to add all these three. Let's say this as 1, this as 3. So when I add 1, 2 and 3, on the left hand side I get log A plus log B plus log C. On the right hand side I take lambda out since lambda is common. So inside the bracket I will be having b minus c plus c minus a plus a minus b. So if we can see carefully, c will be cancelling each other off, a b, and so b, which means so I'll write it here, which means it says, and on the left hand side since it is plus we can write it as log a b c equal to lambda times 0, which will leave log abc equals 0. Then we can write abc equals 1. By indices, we are converting this into indices. Okay, so the first part is done, and then we are asked to prove the second part. So let's see how to prove the second part. So to solve the second part, what I do is I multiply by a, then the second one by b, the third one by c, and then I add them all together. I multiply them and then I add them. So when I multiply and when I add them, I get it as, on the left hand side I will have a log a plus b log b plus c log c equals I would have lambda a b minus c plus lambda b c minus a plus lambda c a minus b. So you know log a, so we can write this as log a to the power a plus log b to the power b plus log c to the power c. And on the right hand side what I do is I take so I open brackets. So when I open brackets I get lambda ab minus lambda ac plus lambda bc minus lambda ba plus lambda ac minus lambda bc. And on the left hand side we can write this as aa bb bc, which is equal to, so if you see carefully, lambda ab, these two cancel off, lambda ac, these two cancel off, these two also cancels off, so it is equal to 0. So we can again say that aa bb bc is equal to 1 by indices method. So that's how you solve the problem number 1. Let's move to problem number 2. So this is problem number 2. So this problem we solve like this. So they have given log 4x equals a, or we can write it write this as log x4 equals 1 over a by logarithmic methods. Also we can write log 12x equals b as log x 12 equals 1 over b. But this we can further write it as, now this is number 1, so we can write log 12 1 over b as log 12, we can write it as 3 times 4, so 3 times 4 this way, so that is equal to log x3 plus log x4 equals 1 over b. But what's log x4? Log x4 is 1 over a, so we subtract log x3, we'll get 1 over b minus 1 over a. So now we have all the requirements we need. They are asking to show log 34 as b over a minus b. Log 3 over 4, using change in base formula, we can write x4 times log 3. What's log x over 4? It's 1 over a. Divided by what it is, 1 over b. It's 1 over a. Solving this, we would get b over a minus b. So that's that. So second one, they are asking us to show log 348 as a plus b over a minus b. Here too we can write this. How we can write 4 times 3. We can write this log 4 plus log x12 by log x3. Log x4 is 1 over a plus, that is 1 over b. Log x3 is 1 over b minus 1 over a. Solving this, we would get a plus b over a minus b. Now we move to the problem number 3. Problem number 3, this is a special problem. This is very important. I want all of you to focus on this problem. So they have given as b equals abc. By index form we can say abc equals a to the power b. Similarly we can write ca equals b to the power q, and ab equals c to the power r. We consider bc equals a to the power p, and then we raise both sides by qr. So when you raise to the power qr, you get a times pqr. Here I write it directly because I guess you know the indices form. Then what happens is, what we do is we write this separately. B to the power qr, c to the power qr. On the right hand side there is no change, a to the power p. Right, so but what's b to the power q? You know, b to the power q is ac, and then c to the power r, c to the power r is ab. Equals, on the right hand side it's a power pqr, and then we further break this down. When you further break this down, you have b to the power c to the power r, q, p to the power q, and a, p, q, r. There is no change. So now what we write is, but we know c to the power r as ab, and we have a r plus q. C to the power r is ab, and what's b to the power q? B to the power q is a. On the right hand side there is nothing changed, a, p, q, r. So here you have a squared, so a r plus q plus 2, and then times bc equals a to the power p q r. But what's bc? Bc is a to the power p, so we have a times r plus p plus q plus 2 equals a to the power p q r. So here if you say a is the base, so we can directly equate r plus p plus q plus 2 QR. That's the final answer. That's how we solve this sum. Thank you guys for watching the video. If you guys like the content that I do, give it a like and don't forget to subscribe if you want to see more of my videos. Hope to see you in another video. Have a good day.